Hola pre-calc peeps, and welcome to the next unit. Your next unit covers everything triangles, and what we're going to start off with is right triangle trig. This should be 100% a review for you, and it should be nice and easy. Alright, so let's start off with solving for the missing variable, and number 1. Going through some of the basic triangle properties here. So we have a right triangle, and right there is a 38-degree angle, and up there is angle alpha. What is angle alpha? Well, you should remember from geometry that all of the angles of a triangle add up to 180. And since we have a 90-degree angle here, I can say that alpha equals 90 minus our 38-degree angle. So therefore, alpha has to be 52 degrees. So far, so good. Easy enough. Remember, if you have any questions, write them down, bring them in, and we will talk about them next class. Next one. Again, we have our handy-dandy triangle. This side is going to be 9. This is our unknown side, B. And our hypotenuse is 25. How do I solve for B? Well, since we have a right triangle, we are going to use the Pythagorean theorem. That tells me that 9 squared plus b squared equals 25 squared, or that b squared equals 544. And we're going to take the square root of that, but you're not going to leave it as the square root of 544. You're going to simplify it and get 4 root 34. Hopefully we're feeling comfortable with examples 1 and 2. Example 3, we have our 90-degree right triangle here. This is going to be side A. This is going to have a length of 18. And we're going to have a 35-degree angle right here. How do I solve for A? I can't use the Pythagorean theorem. I'm not going to use the sum of the inside of angles of a triangle. So instead, SOHCAHTOA. We've already dealt with this from our past unit, and from right triangle trig, this should be familiar to you. Well, I have my 35-degree angle. I have the side adjacent to it and the hypotenuse. So we are going to be using this part of SOHCAHTOA, which says the cosine of my angle equals the adjacent over the hypotenuse. Solving for A, we get 14.74. You may be wondering how many decimals to take everything to. Let's go ahead and say take side lengths to 2 decimal places and take angles to 1 decimal place. Alright, so we just dealt with solving for the missing variable. But now I'm going to tell you to solve the triangle. When you solve the triangle, it means that we are going to find every unknown part of the triangle. So, triangle number 4. There's alpha. This angle up here is going to be 54 degrees. My hypotenuse has a length of 10, side A and side B. What's the easiest unknown to find first? Alpha. So I say that alpha equals 90 minus 54 degrees gives me that alpha has to be 36 degrees. Once you find alpha, you have a little bit of flexibility in solving for A and B. I can start by saying, solving for A, that cosine, A is adjacent to alpha, so the cosine of 36 degrees equals A over 10. Likewise, I could have said that the sine of 54 degrees equals A over 10. No matter which trig function you choose, you're still going to get the same value for A. Taking it to 2 decimal places, we get 8.09. Now let's jump over to B. You can choose to solve for B using the Pythagorean theorem if you would like to, or you can continue with the idea of SOHCAHTOA. That would be the sine of 36 degrees equaling b over 10. Or you could have the cosine of 54 degrees equaling b over 10. Again, either way, no matter what you choose, you're going to get that b equals 5.88. If you would have done the Pythagorean theorem, you would have said 10 squared minus 8.09 squared equals b squared, and you still would have gotten 5.88. Let's go again with one more. Setting up this one. Right triangle. Here's 10. Here's 18. Here's C. Interior alpha, or interior angle alpha, excuse me, and one more unknown angle, beta. Okay, so since we can't solve for alpha or beta first, the easiest thing for us to solve for is C. Well, C equals the square root of 10 squared plus 18 squared. Remember, you are going to reduce that radical, and what do we get? 2 root 106. Excellent. Okay, continuing with this idea, we could solve for alpha or beta. It doesn't matter which. I'm going to choose to solve for alpha, and in doing so, I get that cosine alpha equals adjacent, which is 10, over hypotenuse, 2 root 106. Likewise, we could have said sine alpha equals 18 over 2 root 106. Either way, we're going to solve for alpha, taking it to 1 decimal place for a degree measure, and we get 60.9. Once we have that, we can find that beta equals 90 minus alpha, and we get that beta equals 29.1 degrees. Hopefully, we're feeling pretty confident with how to find all the areas, excuse me, not area, but all the different missing components of a triangle. So now let's go on to some word problems. Definition: the angle of elevation. The angle formed by a horizontal ray and or an observer's line of sight to an object above or below the horizontal is called the angle of elevation or the angle of depression. It really depends on whether you're looking above or below. Because if you're looking above, you're going to have an angle of elevation. If you're looking down, you're going to have an angle of depression. Just to give you some lovely artistic images to correspond with this. Hello, observer. The observer is looking at an object in the sky. Sun, star, UFO, whatever you want to call it. They're looking up at that angle. We have our horizontal. We're going to form our right triangle. There represents our angle of elevation. Going the opposite way, here's our ridiculously tall observer on the cliff looking out at the coastline. Down here we are going to have our water and a lovely boat. Our observer is looking down at the boat. There's the horizontal. Let's make our right triangle. Hello, alpha, which represents our angle of depression. So let's do a couple word problems. Word problem number 1. A fireman is at the top of a fire tower that is 90 feet tall. The fireman looks down at an angle of 27 degrees from the horizontal to see a fire burning. How far is the fire from the base of the tower? You're probably wondering, what's a fire tower? Well, there could be towers on like campsites that observe campfires and keep a lookout and all of that. But there's my fire tower. Impressive, I know. Over here, we have our fire. Oh no, flames. Okay, fire. The tower is 90 feet tall. We want to find how far it is from the tower. Well, our observer looks down at the fire. Where's the 27-degree angle? It's from the horizontal. It's right there is a 27-degree angle. Now, there's 2 triangles here you could actually look at. you could look at the 27-degree triangle. Closing it off here, this would also be 90, and this would be x. If you set this up, you would say which one, so, ka, or toa. We would look at the tangent of 27 degrees would be 90 over x. To solve this, you would have to multiply the x over, divide by the tangent of 27 degrees, and you would take 90 divided by the tangent of 27 and get your answer. The other triangle you could use would be this triangle right here. This triangle here would have an angle of 63 degrees right here. You would set it up that if this is 63 degrees, the tangent of 63 equals our unknown x over 90. Some people prefer to set it up this way because it's easier to solve for x. No matter which method you choose, you're still going to get that the fire is 176 feet, 0.64 feet, goodness, I can't talk right now, away from the tower. Okay, one more and then we're done. Okay, so we have on level ground point A. An angle of elevation of the top of a tower is 57 degrees, 24 minutes. The distance from A to the base of the tower is 50 meters. How high is the tower? Well, let's draw a picture. I'm going to save you my artistic horribleness, and we're just going to say there's point A. This is our tower, which is x feet tall. That's our unknown. This is 50 meters away, and I have an angle of 57 point. We have to convert 24 minutes to degrees. How do we do that? Well, remember, a minute is 1/60th of a degree. So when we divide, we're going to get that is 0.4. All right, easy enough to set up. How do I solve for how tall it is? The tangent of our angle, 57.4, equals opposite over adjacent. Solving for x, we get that the tower is 78.18 meters tall. Don't forget to include your units. All right, now that we are finished, and since this is a review, you guys can try some problems in the book. Go to page 129. Take a look at 19 through 29 odd. Those are going to be the problems. Fill in the missing points of the triangle. And then take a look at 32 through 37 all. Those are going to be the word problems. We're going to come in next class, go over the homework, maybe do a little bit more practice, and you will have a quiz the following class. Enjoy your weekend and have a good one.